Hi, everybody. So I'm going to be talking today about global economic, environmental, and societal impacts of engineering and how it relates to your senior design capstone project. Okay, so let me share my screen and then I'm going to go through a PowerPoint. So sharing it, and now full screen with that. Okay, so hopefully you can see this. Let me take that kind of like off the screen. Okay, so we're going to be talking about ABET requirements related to global economic, environmental, and societal impacts of engineering. This PowerPoint was first developed by Dr. Reticula, and then I have added and edited it, and so. So big thanks to Dr. Reticula for developing the basis of this. Okay. So ABET Outcome 2 is an ability, says that you need to have an ability to apply engineering design to produce solutions that meet specified needs with consideration of public health, safety, and welfare, as well as global, cultural, social, environmental, and economic factors. Kind of a mouthful. Okay, what this really is emphasizing is the need for responsible engineering design. Obviously, this whole capstone design project is about design, but we need to have responsible engineering design, not just technical correctness, but also the broader context in which the design operates. If you can think about it like this, engineering is a profession. Engineers, we learn the science, math, and technology skills, but you must also have a contextual knowledge of those skills. And that's what this PowerPoint is talking about. Okay, so obviously engineering has a profound global impact because we shape infrastructure, technology, and societal well-being, driving economic growth and addressing critical challenges like climate change and sustainable development. A term that I'm going to be mentioning a couple of times in this PowerPoint is global engineering. Now, global engineering envisions a world in which everybody has safe water, sanitation, energy, food, shelter, and infrastructure, and can live in health, dignity, and prosperity. Okay, so about the infrastructure and development. So engineers build a better world. We design and build essential infrastructure like roads, bridges, buildings, and water systems that are crucial for economic development and improving the quality of life. We address global challenges, and obviously some of those challenges we hear a lot about are climate change, resource scarcity, and sustainable development. And again, back to global engineering. This field focuses on addressing the global challenges and promoting equitable access to essential services like water, sanitation, energy, food, and shelter. And kind of when you think global engineering, what I think about is, again, that equitable access to these things. That hasn't always been the case. Okay, so part of the technological advancement, we've got innovation and progress. So we are at the forefront of technological innovation. With that comes a responsibility. That's what this is about. But we're at the forefront of technological innovation, developing new technologies that improve communication, transportation, healthcare, and manufacturing. The technological advancement in digital transformation. We play a key role in the digital revolution, developing software, hardware, and networks that connect people and businesses globally. And then the technological advancement of communication and connectivity. We have advances and we engineer advances in communication technologies like the internet and mobile devices, and they've revolutionized how people interact and share information worldwide. Okay, now let's talk about the environmental impact of engineering. I'm going to give I think there's 5 examples of positive environmental impacts of engineering. The first would be energy efficient technologies. There's been so many changes in this. Engineering plays a crucial role in identifying, developing energy efficient solutions. For example, we're behind developments such as power saving appliances, hybrid vehicles, and green buildings. Then there's renewable energy sources. Engineers have pioneered the use of renewable energy technologies, including wind turbines, solar panels, geothermal energy systems, and devices that harness tidal energy. Three more: pollution reduction. Engineers develop technologies and machinery that aim to reduce pollution, such as emission control systems in vehicles, air purifiers, and waste treatment plants. I worked in exhaust systems at General Motors for a number of years. And boy, I remember when the smog was so thick over cities. It kind of was one of the things that propelled engineers to develop the catalytic converter. And so, I mean, look at this on the left here, this before and after. I mean, we still might have some smoggy days, but nothing like it used to be. It was just wild how brown the sky was in these urban centers. Okay, the next one is conservation of natural resources. By designing methods for recycling and efficient use of materials, engineers help in protecting and conserving natural resources, as shown here, developing the technologies for conserving these natural resources, like for recycling is shown here. And then lastly, the restoration of ecosystems. We also work on projects like just restoring damaged ecosystems, reforesting hillsides, regenerating wetlands, or creating barriers that will halt desertification. I think that should be deforestation. All right. Okay, and then we get into economic growth and sustainability. So in your engineering, your capstone project, you will be talking about economics, such as the bill of materials with the cost of each part, and then how much it would be if you actually produce it in mass. But what we're talking about in this PowerPoint is more like the developing economic growth. So we engineering solutions contribute to economic growth by creating new industries, products, and services, and by improving efficiency and productivity. Next up, sustainable development. Of course, sustainable is a term that's used frequently in this presentation. We're increasingly focused on developing sustainable technologies and practices that minimize environmental impact and promote resource efficiency. And this is not going anywhere. When I remember like designing at General Motors, I mean, we never mentioned like sustainable sourcing of materials, sustainable design, recycling, repurposing. It was just never mentioned. And now it's become a focus. And regardless the industry you're in, you're going to find that sustainability is a term that will be used. Okay, and then finally here, global collaboration. Engineering products often involve international collaboration, fostering knowledge sharing and promoting economic development across borders. Excuse me, economic development across borders. Okay, and now let's talk about societal impact of our engineering. First is improving the quality of life. Engineering solutions have a direct impact on people's lives, improving health, safety, and well-being through advancements in medicine, sanitation, transportation. We try to address inequality. Global engineering aims to address inequalities in access to the basic services and promote a more equitable world. You know, that fits into the whole global engineering thing, more equitable world. And lastly here, ethical considerations. Engineers have a responsibility to consider the social, environmental, and ethical implications of their work and to prioritize the well-being of societies. Okay, so now let's talk about the specific ABET requirements and how they're going to be involved in this class. Okay, so this is related to what we're talking about right now is performance indicator 2.1. It comes from outcome 2. Outcome 2, it was on, I think, the second slide. I'll reiterate, it's an ability to apply engineering design to produce solutions that meet specified needs with consideration. It's this whole mouthful thing: public health, safety, welfare, as well as global, cultural, social, environmental, and economic factors. So this is the outcome and that ABET sets. And then within the outcome, our ME program has developed performance indicators. So what we're going to talk about right now is performance indicator 2.1. And with it just has to tying back to outcome 2. You need to formulate a problem statement that clearly describes the need for the design. So what do I mean by need for the design? Well, it goes back, how we interpret that, it goes back to the design needing to represent obligations and or requirements as they relate to public health, safety, welfare, as well as global, cultural, social, environmental, and economic factors. So your senior design capstone in 4201, and then it'll continue in 4202, will be measured using this rubric. Unsatisfactory would be you're unable to formulate the problem statement. You don't identify the needs of the design. Nobody wants to be there. Developing would be that you have a partial formulation of the problem statement, but you're missing some key needs. Satisfactory would be that you formulate the problem statement with most of the key needs, and exemplary is that you formulate the problem statement to clearly with all the key needs. Okay, so again, we're looking at performance indicator 2.1, formulating the problem statement that clearly describes the need for the design, with a need being defined below. So in this type of class, you have a lot of time to work on this, your report, your project, you work on it, you revise it, so many iterations, you revise it. I expect that every team will be exemplary because you have enough time to make sure that you do formulate the problem statement clearly with all of the key needs. Okay, so my expectation is that you guys will all be exemplary. There are some other ABET performance indicators, like say something related to, I don't know, heat transfer. And let's say in heat transfer, we want you to know these different things. Well, you might not get to exemplary because, there's a testing condition and maybe you don't quite get to exemplary. Because you end up getting a B or a C in the class and you're not exactly exemplary, some of it, but not all of it. In this class is different because you have time to revise it and make sure you do get up to exemplary. And so that's why you should all be targeting exemplary. That's why I expect you all will be exemplary because of the time that you have to do it. Okay, so that is this presentation, and as always, you can contact me if you have any questions, and I will get out of this. I'll stop sharing. Well, I guess I'll go ahead and turn this off now. Okay, thanks for your attention. Bye.